Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery. Give us 10 minutes and we'll give you the universe.
And I'm Anna. It's great to be with you.
Today we're talking about the ultimate fate of the universe. Is its expansion slowing down? We'll also check in on a Mars orbiter that's been moonlighting as an interstellar photographer and get an update on a scrubbed launch.
Plus, a baffling, record-breaking flare from a distant black hole and a fascinating new paper that asks, could alien probes already be in our solar system?
It's a lot to cover, so let's jump right in. Anna, start us off with this universe-altering news.
Let's do it. The main headline is that our universe's expansion might be slowing down. This feels counterintuitive to what we've understood for decades.
It really does.
For a long time, the standard model of cosmology, which we call lambda CDM, has been built on the idea that the universe's expansion is accelerating, driven by a mysterious force called dark energy.
Right, the cosmological constant, the lambda in lambda CDM.
Exactly. It's been treated as a constant, unchanging force pushing everything apart. But new research analyzing data from various cosmic probes and telescopes suggests that dark energy might not be constant at all. It might be evolving and even weakening over time.
Evolving? What does that mean for a fundamental force of the universe?
It means that dark energy could be something more dynamic, what some physicists call quintessence. Instead of being a static property of space-time, it could be a field that changes over cosmic history. This new evidence suggests its repulsive force might be decaying.
Wow. So if the outward push is getting weaker, what happens then?
Well, that's the most dramatic part of this story. If dark energy continues to weaken, the fundamental force of gravity, which is always pulling inward, could eventually win the cosmic tug-of-war.
And that leads to the big crunch.
Potentially, yes. Instead of expanding forever into a cold, dark, big freeze, the universe's expansion would slow, halt, and then reverse. Galaxies would start rushing back towards each other, eventually collapsing into an incredibly hot, dense singularity, much like the state before the Big Bang.
It's a mind-bending possibility. So, is the Big Crunch our new official destiny?
Not just yet. This research is still challenging the prevailing model, and a lot more data is needed to confirm it. But it's a huge development that has cosmologists everywhere buzzing. It just reminds us that the universe is still full of profound mysteries.
Absolutely. Well, let's pull our focus from the edge of the universe back into our own solar system. China's Tianwen 1 orbiter has sent back some incredible new images.
That's right. While its primary mission at Mars is complete, Tianwen 1 is in an extended mission phase, and it has accomplished something remarkable. It managed to capture detailed images of an interstellar object known as 3I/Atlas.
An interstellar object. So, a visitor from another solar system like Oumuamua?
Precisely. These objects are incredibly rare and difficult to observe. Getting high-resolution images of one from a spacecraft already in deep space is a major technical achievement. It gives us a close-up look at a building block from another solar system.
What can we learn from it?
The data helps us understand its composition, shape, and rotation, which tells us about the conditions in the planetary system where it formed. It's also fantastic practice. Practice? For what? For their next big mission, Tianwen 2. That mission is designed to visit a near-Earth asteroid, collect samples, and return them to Earth. Successfully tracking and imaging a fast-moving distant object like 3I/ATLS proves their capabilities and provides valuable data for planning that ambitious sample return mission.
Very cool. Now for a quick update from the launch pad. It was a no-go for United Launch Alliance yesterday.
Yes. Unfortunately, the much-anticipated launch of their Atlas V rocket carrying the Viasat-3 F2 satellite was scrubbed.
They called it off late in the countdown. Any word on what the issue was?
The official reason cited was an issue with ground systems equipment. These are complex machines and safety is paramount. The good news is they've already rescheduled the launch for the following day.
Fingers crossed for a successful liftoff. This is an important satellite, right?
It is. It's the second of 3 satellites in a constellation designed to provide high-speed, affordable broadband internet service to most of the globe. So we'll be watching closely and wishing them the best on the next attempt.
All right, from a launch delay back to the deep cosmos. This next story sounds like a real head-scratcher for astronomers. A supermassive black hole has unleashed a flare of epic proportions.
It really is a puzzle. This flare, spotted by the Zwicky Transient Facility, or ZTF, is not just bright, it's the longest-lasting flare we've ever seen from a supermassive black hole. It has been going on for years and shows no signs of stopping.
Years? I thought these things were usually, transient, and that's what the T in ZTF stands for, right?
Exactly. Usually when a star gets too close to a supermassive black hole, it's torn apart in what we call a tidal disruption event. That causes a flare that typically lasts for a few weeks or months. This event is on a completely different timescale.
So what do they think is causing it?
That's the mystery. The leading theory is that it's an exceptionally massive star, perhaps 100 times the mass of our own sun, that has been captured and is slowly being consumed. But even that doesn't fully explain the flare's duration and steady brightness.
It must be an incredible opportunity for research, though.
An unprecedented one. Because this black hole is so distant, we're seeing it as it was in the very early universe. Studying this long, slow meal gives us a unique window into how supermassive black holes grow and affect their host galaxies in the cosmic dawn.
From one mind-bending topic to another, our final story sounds like pure science fiction, but it's being discussed in a serious scientific paper. Are we talking about alien probes?
We are. Specifically, the paper discusses the concept of von Neumann probes. These are theoretical, self-replicating robotic probes that could be sent to explore a galaxy.
Self-replicating. So one probe arrives in a new star system, uses local resources to build copies of itself, and then those copies travel to other star systems.
That's the idea. It's an incredibly efficient way to explore the vastness of the Milky Way on a timescale of millions of years rather than billions. The new paper makes a bold suggestion that if an advanced civilization has ever created such probes, they could already be here, in our own solar system.
Okay, wow. So where should we be looking?
The paper proposes we should be actively searching for their technosignatures, evidence of their technology, and it singles out a prime location for the search: our moon. Why the moon? Because it's a stable, geologically dead world. A probe could land there, use lunar resources to replicate, and its artifacts could remain undisturbed for hundreds of millions of years. Unlike Earth, there's no weather or geological activity to erase the evidence.
So we should be scanning the high-resolution images we have of the lunar surface for anything out of place.
Exactly. It's a long shot, of course, but the authors argue it's a search worth conducting. Finding even a single non-terrestrial artifact on the moon would be one of the most profound discoveries in human history.
And what a profound thought to end on. From the fate of the universe and interstellar visitors to bizarre black holes and the possibility of ancient alien technology on our doorstep. What a day in astronomy.
It certainly shows that there is always something new to discover, no matter where we look. Thanks for joining us today on Astronomy Daily.
We'll be back tomorrow with more news from across the cosmos. Until then, be sure to subscribe wherever you get your podcasts so you never miss an episode. Clear skies.
Astronomy Daily.